So now we're going to run through properties and applications of logs. Okay, so let x, y, and a be positive numbers where a is not equal to 1 and r is some real number. Okay, so r is a real number. Okay, r is a real number. Then the following is true. Log base a of a to the r, this is our log trick to get rid of a base, we log a it, gets me r. Okay. Log base a of x raised to the r. Okay, what happens? This is called the power rule. The r here comes out in front. So the r comes out in front and I have log base a of x. Right, this is going to really help us out here in a little bit. Okay, that very powerful rule right here. Okay, next rule, log base a of x times y. This is an expanding rule. To expand, this becomes log base a of x plus log base a of y. Now, you might be asked to take this sum here and condense the log. And so then you could condense it to bring it into one argument here. So depending on what they're asking, if they want you to expand, go out from multiplication to adding. And then if they're wanting you to condense, you take the sum of logs and it's equal to the log of the product of the arguments. Same thing goes for the division. Log base a of x divided by y. Remember, these are logs are exponents, so same base, add the exponents when you multiply. When you divide, what do I do with exponents? I subtract the exponents. Okay. Same story. If I want to expand, spread it out. And if I want to condense, okay, I go back to just one log. That's the idea. Okay. One last rule that runs up, and we've talked about it a couple of times, but here it is formally. Log base a of x. To type this in your calculator, you do log of x divided by log of a. Now, if you don't like the log button, you can use the ln button, and it still gets you the same answer, just as long as you use whatever you use in the top. If you use a log up top, you use a log down low, okay? So if you use a ln in the numerator, use a ln in the denominator. So hopefully that helps you out there. Change of base rule is really useful. So all those properties, we're about to use the fire out of these, okay? So I'm going to show you how to condense and how to expand different log expressions, okay? So let's start. Use the properties above to expand expressions as much as possible. Expand it as much as possible. So what does that look like? So take log base 4 of 16, x to the 5th, y to the square root, right? Okay. And now we're going to expand it. Okay. So let's see if we can do this. All right. So this is equal to, well, all these are getting multiplied together, right? So this is the log base 4 of 16 plus the log base 4 of x to the 5th plus the log base 4 of the square root of y. Okay? Now, what can I do? Can I simplify this first one any? I think so. How do I simplify it? Set that equal to, let's set it equal to z. Okay, log base 4 of 16. Now, if I turn this to exponential, how do I get rid of log 4? The base is 4, so I raise it 4 on both sides. So 4 to the z equals, that cancels, 16. What do I raise z to get 16? Z is going to be 2. Okay, so z is 2 here. So this whole thing right here reduces to 2. So that makes that easier for sure. Okay. What about, let me make this a little bit smaller so I have better room. Okay, so that's just my little scratch work there. So that equals 2. What can I do with this expression here? Well, the exponent, remember we've got a power rule. The exponent comes out front, right? So let's do that. So let's bring the 5 out front. This is log base 4 of x. Okay. And then what can I do with this square root? Well, a square root, I can convert this to y to the 1/2. Rider and the horsey. The rider goes in the house and the horsey goes outside, right? So the square root that has an index of 2, that should be on the inside of your parentheses there. Okay. And so then what can happen with my exponent? It can come out front. So I have 2 plus 5 log base 4 of x plus, and then the 1/2 comes out front, and I have log base 4 of y. Now I've expanded as much as possible because each of my logs, the argument inside is just an x here. It's just a y there, and that's what my goal is. Okay. So that right there is the expanded form. Let's try another one. Let's do the log of log 1000 raised to the 500x. Oh my goodness. So let's just start with the inside and try to work our way out. Okay? So let's just look at this piece here. Log of 1000 raised to the 500x. This is equal to the log, and then what goes in here? It's this piece right here, right? The 500x comes out front, exponent rules. 500x multiplied by what? Log 1000. Okay. Now, log 1000, can I do anything with log 1000? Well, this is a log base 10 when there's no number there, right? So if I had like a z equals log base 10 of 1000, okay, if I raise both sides to the 10, I cancel that. I get 10 to something, I don't know what it is, right? Almost wrote it. Equals 1000. Well, what do I raise 10 to get 1000? I raise it to 3, so z equal to 3. So this piece in here is 3. So what do I have? What do I have? This is equal to log 500x times 3. Okay? But I can factor this down even further, can I not? This factors to log, and then I have 5 times 100 times x times 3. Okay? Now, I see this 100 here. This can break down. But what do I know? The base here is a 10. So I'm going to leave that because I know that I can rewrite this in terms of 10. This is 10 squared, okay? So I'm going to hold off on splitting that up anymore, but I'm going to write it out. So log of 5 plus log of 100 plus log of x plus log of 3, okay? And what can I do? This is done, and this is done. But this one right here, okay, log of 100, this one can simplify. Why? Let's try it. So just let z equals log base 10 of 100, right? Base 10 when there's no base. Raise both sides to the 10 power. So what do I raise 10 to get 100? This is equal to 2 here. So this answer, the final answer, is what? It's log base 5 plus 2 plus log x plus log 3. Okay? That is the most expanded form that we can get right there. All right? Now this next one here, this next one's really tricky. And I promise you, if you're not paying attention right now, you're going to miss this one. in your homework or on an exam if it ever popped up. Okay, so you got to be very careful with this. What I see a lot of students do here, they see, oh, it's plus inside. So now this is going to be log base 5, 75x plus log base 5, 25y. And that is completely wrong. Do not do that, okay? That's really, really bad. No, okay? The only way we can expand if we using our expansion rule is it's a product of two things, not adding inside, it's a product. So how do we make this into a product? I have to use this little thing that people always forget about, GCF. So inside, what can I factor out of both of those? I can factor 25 out. So 25 times 3x plus y, okay? Now at this point, I have a product, and I can split the product up to log 25 plus log base 5, 3x plus y, okay? This I cannot do anything else with, but this one right here I can simplify. Z equals log base 5, 25. How do I get rid of a log base 5? I see the 5. I'm going to raise the 5 on both sides. Okay, let me do a different color so you can see it. So it's 5 to something equals 25. What do I raise it to? I raise it to 2 because 5 squared is 25. Okay, so my answer is 2 plus, see that, equals 2 plus log base 5, 3x plus y. Okay, so hopefully that helps you out with expanding. Now let's go the other way. Okay, let's condense. Use properties of logs to condense. All right, condense the expression as much as possible. Okay. So I want to condense as much as possible. So I start in an expanded form, log base 3 of x minus log base 3 of 2z, and then plus 4 log base 3 of 2y. How do I condense this? Okay, well, we have to think about this for a second. When I have subtracting logs, that means I divide. All of these are base 3, so I can combine everything. My final answer is going to be log base 3 of something. Okay, something over something. How do I know there's a fraction there? Because of that negative sign there. So I'm going to put this down here just, and we'll come back to that in a second. But let's combine this. Since it's a negative here, this tells me that's log base 3 of what? X divided by 2z, okay? And then it says what? 4 log base 3 of 2y, right? Now what happens with the 4 here? The number out front comes back to the exponent here. So this is what? Log base 3, x over 2z, and then plus log base 3 of what? 2y raised to the 4th. Okay, the exponent comes back inside up there. The power rule in reverse. Okay, so your number out front comes out like that. Now I've got a log 3 and a log 3, and there's a plus in between, so that means that I multiply. So this becomes log base 3 x over 2z multiplied by 2y to the 4th. Now this can clean up, right? Let's do some scratch work over here. So let's see if we can simplify this. X over 2z times what? 2 to the 4th and then y to the 4th, right? Well, there's 1, 2 here, and there's 4 up here, so this becomes 2 cubed, okay? So 2 cubed is 8, and then times x times y to the 4th over z. So my final answer is log base 3 of 8x y to the fourth over z, which is exactly what I predicted, right? Log 3 something over something, right? So that is the condensed version. So hopefully that helps you see what to do there. Okay, let's do another condenser. So ln, so let's do 2 ln x minus 1/2 ln y minus ln 1 over x. Okay. All right. So what's going on here? Well, first thing I want to do is I want to make sure I've got the same ln on the outside. I want to end up with ln of something over something. Okay. But right now I've got numbers out front that I need to take care of. So this number can come up. It becomes ln of x squared. Okay. What about this one here? I can take this 1/2, bring it up, so I have minus ln of y to the 1/2. All right, I didn't have to, you don't have to take up, you could if you wanted to take up this negative, bring it up to the exponent, but you don't have to. You can just take the number and put it up on the exponent inside your argument in here, okay? And then this last one, like I said, we can leave that negative out there because we know what to do with negatives. Okay, so what's going to happen here? Subtracting means division. So what's positive? All right, what's positive? Well, this one is positive, but these two look like they're being subtracted. They're negative. So the negative is in the denominator and the positive is in the numerator. Okay, so this becomes what? Natural log of x squared over what? Y to the 1/2. And then 1 over x. Okay? Now, we've got to simplify this. That answer, you know, that gets you like 3 out of 5, but we want to get 100%, right? So we need to keep change flip. So simplifying inside here, this is x squared over, what's in the denominator? It's y to the 1/2, and then multiplied through here by 1 over x, that gives me x in the denominator. So I have a something divided by something. So what do? I keep change flip. I keep x squared the same. I change division to multiplication, and I flip the denominator. It becomes x over y to the 1/2. Okay? So what does this become? This becomes x squared times x, which is x cubed, over y to the 1/2, which is really the square root of y. If you really wanted to, you could write square root of y there. That's fine. So what is the answer? My answer is the natural log of x cubed divided by the square root of y. That will be your final condensed simplified answer. Okay? One more of these bad boys. Say I have 3 parentheses natural log cube root e squared minus natural log xy, close it. Okay, and I want to condense this. All right, I want to condense this. Okay, so what do I have right now? Well, I've got this on the inside. Let's just work inside and then go out, right? So subtraction means that I need to do what? Means that I need to divide. So I have the cube root of e squared, okay? And then I have divided by x, y. And now that's all multiplied by 3. Now what can happen here? What can happen here? The 3 can come up and everything gets raised to the 3rd power, right? So everything in here, so the cube root of e squared gets cubed, and then xy gets cubed. Everything in there gets cubed, okay? It all gets raised to that 3rd power. That's what's going to happen there. And so then what? This simplifies. The cube root of something cubed just becomes what the something is inside, right? So this is e squared inside. And then in the denominator, it's x cubed, y cubed. And this is my final answer here. That is condensed as much as you want. So for your homework, they want each answer as a single log with coefficient 1 if you're expanding. Okay? If you're condensing, all you got to do is make it into one log. Okay? And put everything else on the inside in here. Okay, that's the idea. But to expand, you've got to press it out until everything is expanded enough that when you look at it, everything in here, there's one x with the coefficient of 1 in front of it. Any variables have a coefficient of 1. So you look at this, coefficient 1, coefficient 1. Everything's expanded out, expanded as much as you can expand. Okay? Condense, all you got to do is put it into one log. Okay? So let's do one more. And this is just to illustrate your change of base, which I already have a little bit, but I just want to make sure. So finding x. So if you're given 2 to the x equals 9, okay? How do I get that exact number? All right, how do I get that exact number? Well, the base here is 2. So to get rid of the base 2, I'll log 2 both sides. Okay, so log 2 both sides. That cancels. I get x equals exactly log base 2 of 9. Okay, so that number there is exactly the solution. So if they ask for the exact solution, this is what they want. Okay, so they want you to write this. So that's what I'm looking for. Now, if they ask for an approximate, you need the change of base formula. And to do the change of base here, it's the log of 9 divided by the log of 2. So to show you that in action, so let's clear this out. It's the log of 9, close parenthesis. Ooh, let me clear that. Log of 9 divided by the log of 2. Enter. 3.169. So this is approximately 3.17. Okay, depending on how many decimals they want you to round to, you do whatever it says to round to. Okay, so that's what they're looking for right there. Now, you could have used, instead of log, you could have said ln. You could have said ln of 9 divided by ln2. Do you get the same thing? Well, let's check it out. ln 9, divide, oh my goodness, I'm having trouble here. Divide by ln 2. Okay, let me see if I can delete that. Okay, let me just clear all that. Okay, ln 9 divided, oh my goodness, divided by ln 2. Enter, and I get the same exact thing. So if you want it, if you like using logs better, great. If you like using ln's better, even better. Okay, they'll both get you the same thing. Okay, if I had an expression like this, the natural log of e squared, what do you know about natural log and e? They are inverses of each other. The property, whenever I square something, the exponent comes out front. So this becomes 2 times the natural log of e. Now, what happens here? This ln of e, since they're inverses of each other, they cancel out. And so I get 2 times 1. And so my answer is just 2 here. So that's a simplifying trick for you. If you want to get rid of an e function, all you need to do is ln it. And then that gets you back to x. Okay, if you want to get rid of an ln x, you just need to e it, and then that will get you back to x. Okay, so they're inverses. These two functions are inverses of each other. Okay? All right.